Good day or good afternoon to your class, whichever time you are seeing this recording. This is a recording for our course EE3244 or Electrical Apparatus and Devices, mainly transformers in the Electrical Engineering program in the online education setup at Ateneo de Davao University. So in this recording, we will discuss 2 weeks worth of lesson about transformer theory, part one, which tackles ideal transformer, and part two, which tackles practical transformers. So, ano importante na matakal na to ang both ideal and practical transformers. This is because para mas masabtan nato ang operation sa isa ka transformer. So magsugod ta sa ideal, basically ang ideal transformer avoids resistances, impedances in case of AC man ta. And because ina-avoid na to ng mga resistances sa transformer, we are also avoiding the losses na ma-incur sa sulod sa transformer as it operates. So muna siyang conditions 1 to 4. And in all cases of transformer, the turns ratio between the primary and the secondary winding is given as N1, or the turns ratio at the primary side, divided by the turns ratio on the secondary side, the number of turns rather on the secondary, primary and secondary side is what we known as the turns ratio. So we have two conditions under ideal transformer. First, we'll start with the no load condition, or kanang condition na walay connected na load sa tong transformer. So nana siya kuryente pero walay load. So meaning walay load current na moagi sa ato ang secondary winding. So another condition is that the winding resistance or impedance is not yet relevant in the calculations. So that's the main point kano ideal transformer siya, and the EMF and the terminal voltage and the induced EMF are always equal. This is because wala pa nato gi-consider ang kanabitang murag voltage drop sa windings. Then, mani siyang itsura sa aton transformer, basic na kanabitang circuit equivalent niya. Then what you're seeing at equation 2.1 is ang proportion between voltage and the number of turns. So makita nato dere that the voltage is what we call this directly proportional to the number of turns in our transformer. So kung unsa nang number of turns nato sa primary winding, inana po ng corresponding voltage niya, kanang unsa tawag mo, terminal voltage. Then consequently inana pod ang uh, direct proportionality sa secondary winding. So that's equation 2.1. Then makita nato diri sa second diagram is ang kanang equivalent na jud na circuit diagram sa transformer. So makita nato diri ang kanang bitang conditions for an ideal no load transformer. Ang voltage, induced EMF ug ang terminal voltage are in phase. So meaning walay galag in between them kay wala pa ta nag-consider og impedances as of this point. Then we have V1 and V2 as the equations which calculates the terminal voltage, V1 for the primary side and V2 for the secondary side. So V1 is equal to 4.44 F n sub 1 phi max. Then V2 is equal to 4.44 F n2 phi max. So ang difference nila is actually kanilang N1 and N2. It is because ang frequency F, which stands for frequency, usually 60 hertz, and then the phi max, or the maximum value of the flux, which is measured in Webers or other units of measure. These are shared parameters between the primary and the secondary side. So dili maglahi-lahi ang frequency sa primary and secondary side. And ang 44 pod, 4.44 na kuan is derived from the 2 pi over square root of 2, which represents the root mean square value of the voltage. So equal pod na siya kay shared parameter man na siya between the primary and the secondary. So if wala pa ninyo na encounter, ang root mean square is kana bitang murag this is just a rough definition kanang murag what do you call this, measurable na kana bitong amount of voltage with any measuring devices, like for example kana oscilloscope or kana multimeter. So dili dyan ang peak to peak na voltage ang iyang gina-measure, kundi ang RMS lang, which is equivalent to kanang square root of 2 divided by square root of 2. Not sure. Then when an ideal transformer has no load connected to it, both current and impedance is not included or is not relevant yet in the calculations. So karon let's move on with an ideal transformer with load. So ang difference ani niya with no load is that naanatay load na connected, which is represented by a load resistance or impedance, which is in this illustration is represented by ZL. So resistance or impedance, um, since we're dealing with AC electricity in this particular course, so it is proper that we use the term impedance. So na siya, vector quantity na siya. So we can calculate the magnitude of the current, which directly depends on the value of the impedance ZL as observed in Ohm's law. Then, in addition to equation 2.1, kani, we also have an equation which involves the number of turns and the current, in which, in this particular case, the the magnitude of the current is inversely proportional to the number of turns. So if voltage is directly proportional to the number of turns, the current in this case is inversely proportional. So kung mudako ang voltage, mugamay ang current, or kung mugamay ang voltage, mudako ang current. So inana ang kana bitang murag consequence sa pag-step up o step down sa voltage in a transformer, and this also illustrates na energy that passes through the transformer is conserved. Then combining equations the 2.1 and 2.4 katong current and voltage, we have V1 I1 is equal to V2 I2. This is a very handy equation na ma-relate ang voltage and currents for both primary and secondary. And this is the equivalent circuit diagram and the phasor of an ideal transformer with load. So as you can see, ang current nagalag na siya behind the voltage. It is because of the influence of the impedance ZL. Then, since the impedance ZL draws current from the secondary winding, we can solve either the current or the impedance, whichever is given sa problem. So, kuha ni siya, Ohm's law. ZL is equal to V2 over I2. Consequently, the impedance in the secondary can be replaced by an equivalent impedance in the primary circuit insofar as the effect at the source terminal is concerned. So, in this particular diagram, nakakonect ang ZL nato sa secondary winding, pero napod na siya equivalent na kanabitang reflection ang ato ang ZL or load impedance sa atong primary side, which is represented by Z with apostrophe L. Then Z apostrophe is equal to N2 over N1 squared ZL. So that's how we convert the equivalent impedance. So important ang topic on equivalent impedance, or important siya nga kanabitang ma-observe na to sa calculation. It is because installing a transformer in an existing electric power system requires that the equivalent impedances are more or less equal. So, kailangan na to siya ma-measure. Manang important na bitaw makabalo po ta sa concept sa kanang equivalent impedances on as reflected on both primary, secondary, or vice versa. And kung naatay actual na transformer, ma-measure natin siya on both primary and secondary terminals sa transformer. But now let's move on to an example. So natay isa ka example dere. A 60 Hz 100 kVA 2400 to 240 volt transformer is used as a step-down transformer from a transmission line to a distribution system. So, number one, letter A, determine the turns ratio. B, what secondary load impedance will cause the transformer to be fully loaded, and what is the primary current? C is find the value of the load impedance that is referred to the primary side of the transformer. So, nalang ko i-correct gamay ani. This is supposed to be 200. 200 kVA na siya. So, solution, we have for letter A, the turns ratio is basically kaning 2,400 over 240 or 10 is to 1. So, ang atong A or turns ratio is equal to 10. Ganyan lang. Very easy. Then, letter, what do you call this? B. Letter B, um, kailangan na natin calculate ang secondary load impedance at the condition where the transformer is fully loaded. So, on full load condition, the transformer capacity is maxed out. So, kaning 200 kVA karon, mo na siya tong gina-assume nga na max out na siya nga capacity. So, referring to the secondary, kaning kVA is basically murag power man na siya. So, power is equal to voltage times current. So, V2I2 is equal to 200 kVA or 200,000 volt amperes. So, kung pangitaan na to si I2 is equal to 200,000 volt amperes divided by V2, which is, in this problem, 240 volts. Cancel on V, we have 833.33 amperes. So, muna siya tong secondary current I2. Dako kayo. Then, from this I2, we can solve Z. ZL, secondary load impedance. This is equal to V2 over I2. Our V2 again is 240 volts. Then, our I2 is equal to 833.33 amperes. And our ZL is equal to 0.288 ohms. Then primary current, ma-compute na nato si primary current because we already know the value of the secondary current. So I1 or primary current is equal to the secondary current I2 over the turns ratio, letter A. This is equal to 833.33 amperes divided by 10. And so our primary current is at 83.33 amperes. Ito lang din siyang ipang-highlight itong mga final answers so that it's easy to check whether tama siya or mali. Then the third that we will calculate is the value of the load impedance that is referred to the primary side of the transformer. So, ang equivalent, ang reflected na impedance sa primary side by the load impedance. So, we will represent the load impedance on the primary side as Z apostrophe L. So, this is equal to N2 over N1 squared ZL. Or since nakuha naman natin turns ratio, this is simply 10 squared Then our ZL is 0.288 ohms. So our Z apostrophe L then is 28.8 ohms. So yun lang. I think ang calculations with transformer basically involves a lot of formulas pero not too much na mahimo siyang overwhelming. It is just upon us to to be creative with playing with the formulas as unsa ning give dere. Dali lang ni siya timanan class. This is just a form of practice and this is just the first part. So for now, let's move to the second part of our lesson, which is about practical transformers. So basically, sa practical transformer, ma-count na nato ang mga losses ug ang mga internal resistance, reactance, resistance and reactance equivalent na niya impedance which is a vector quantity. So I hope na you have done some skimming with this material kay i-upload man ako ni siya in advance. So na yung mga conditions dari which tantamounts which is relevant rather for our calculation of a practical transformer. So since we're dealing with AC also, as a reminder, we will be using vector quantities in our calculations involving transformer problems. So practical transformer also have two conditions. We have no load conditions and with loaded conditions. So specifically sa no load na practical transformer, natin magnetizing current IM and we also have core loss current IC because of the finite permeability in the core. So the core loss current is IC is equal to the power or the core loss divided by the EMF produced in the primary winding. So man siya equivalent circuit sa practical transformer. So makita na to si I sub O. Makita na to si I sub O here. Then si IC, then si IM. So IC plus IM is equivalent to I sub O, which is exactly that one for the primary side. So na natin mga internal mga impedance. The magnetizing current IM is directly proportional to the flux and is in phase with the flux. Kaya mo na siya ang nag-produce sa flux na to mismo, magnetizing current. So based on the diagram above, the no-load current IO kani is the vector sum of core loss current IC and magnetizing current IM. So since we're dealing with kanang vector sum, so kanang murag resultant of vector bitaw na kanang murag hypotenuse. So we have equation 3.2. And the no-load power factor is given by cosine theta is equal to IC over IM. Then the equivalent core loss resistance and the equivalent reactance, sulat-talan ako dari mo na siya, Z is equal to R plus JX. Just a reminder naman na siya ang basic na itsura sa itong vector quantity. Can also be used to solve the core loss current and magnetizing current. So, aside any mga formulas from equations 3.1 to 3 through 3.3, we also have equation 3.4 and 3.5. Which is an alternative to find the core loss current and the magnetizing current. So core loss current is equal to EMF for a primary winding over the resistance at the core. Then IM or the magnetizing current is equal to the induced EMF or the voltage EMF at the primary side divided by the magnetizing reactance or XM. And the corresponding power loss, PC, is equal to IC times E1, equation 3.6. Then the second, what we call this, condition for a practical transformer is the one which has a load in it. So in addition to these items, kani conditions sa no load practical, we have another two conditions for the loaded practical transformer. So winding resistances are now significant, and the flux lines are no longer confined to the core and link both windings, resulting to flux leakage losses. So ang flux lines daw kay dili na siya kana bitong kuan, dili na siya loss free kay tungod na may kuan na naman jay flux na dili jud mo subay sa path, kumbaga kanang murag mga saag ba, so manang natay flux leakage losses. Then what you're seeing now is the equivalent circuit diagram of a practical transformer with load. So ganina wala pa ta ani nga portion dere, karon nga loaded na ta as we expect na jud tay load represented by ZL. So di ka na siya na naka-complicated class. As shown in the diagram, the practical transformer is just the same with the ideal transformer, only with external impedances. So na siya yung mga impedances. Mo to siya yung ganina na kapag practical na natay mga impedances. And the induced voltage E or EMF and the impressed voltage V will differ by an impedance drop as shown in equations 3.7 and 3.8. So kaning nag-cause sa impedance drop is actually kani sila for the primary side and then kani sila for the secondary side. So mana siya ang nag-cause nga no dili equal atong E ug V. So for the primary side we have V1 is equal to E1 times I1 plus I1 times the what we call this, the line impedance. And then the secondary side, we have V2 is equal to E2 plus I2 times line impedance R2 and X2, XL2. So, mapo ni siya ang equations 3.1 to 3.8 na dula-dulaan lang gyapon nato dira ta magtuyok-tuyok para ma-solve ang mga practical transformers with or without load. So now let's move to another example involving practical transformers. So the equivalent circuit of a single phase transformer is shown above with the impedances in terms of the primary side. The secondary to primary turns ratio is 5:1. Find A, the primary input current and power factor, and B, the secondary terminal voltage. So kaning diagram daw as stated in the problem, kuan lang ni siya kanang in terms of the primary side. So tan-awon nato karon kung sa tong naa sa textbook nato specifically kani. So man ni siya ang itsura sa kana bitong equivalent circuit in terms sa primary side kani. Then kung in terms sa sa secondary side, mao na po ni siyang itsura niya. Dili na kabalakan na medyo complex kay siya nang kay it's just a matter of equivalent circuit diagrams. Ang kanang equivalent circuit diagrams exactly man na siya ang kanabitong gibuhat para mas ma-simplify ang atong approach to solving the problems. But balik this is a bit less complicated, not so overwhelming. But man siya ang equivalent na transformer circuit diagram sa primary side. So magsugod ta una og solve sa primary input current. We have ang primary input current nato is I1. Pero in order to solve I1, isolve sa nato si I2. So I2 is equal to V over Z. So in this case, we have, what do you call this? 230 volts divided by kaning vector addition ani nilang duha. So we will write 0.2 plus J 0.9 plus 8 plus J6. So mga complex na siya ng mga numbers. And this is, diretso rin sa calculator, this is equal to, naka-complex mode lang dapat ang calculator, don't forget, equal to 21.46 angle negative 40.08 amperes. Sama na siya itong I2. I2 being kani. Then, so solve na punta sa I sub O. Kanina po datong isolve na portion sa circuit diagram. We have IO is equal to 250 volts over the parallel sum of these two quantities. We have 400 times J 200 over 400 plus J 200. Pwede na po na sa diretso sa calculator, and the answer is 1.286 angle negative 63.43 amperes. So don't forget the units. Then, ang ato ang primary current karon, in fact, maklaro man nato na siya dari sa diagram. Muna siya. The primary current is equal to I sub O plus I sub 2. So basically, add lang nato ni sila 21.46 angle negative 40.08 plus 1.286 angle negative 63.43. Atong I1 is equal to 22.65 angle negative 41.37 amperes. So, ano siya to ang answer? Bati lagi. In which, ang scalar nga quantity sa atong I1 is kaning 22.65 amperes. And then the power factor PF is equal to cosine theta cosine of kaning nga angle negative 41.32 is equal to 0.75. So maingon na to siya nga power factor lagging. It is because of the negative angle sign. So na siya sa baba kung mag-drawing taog ka ng vector diagram. Tapos mapansin po na to na siya nga power factor lagging kung naka-plus na siya. Just some rough indications but not always true, so you have to be careful about that. Then the next thing that we will solve, letter B, is the secondary terminal voltage. So ang secondary terminal voltage is actually kani siya. Tawag na to na niya is V2. So to get V2, we must first solve V apostrophe 2. Must first solve. So kanang V apostrophe mano siya ang voltage referred to the primary side. Voltage at the secondary winding referred to the primary side. Yan. Then V apostrophe 2 is equal to, balik ta aning equation, asa man to siya. Kani, balik ta ani nila. equations 3.7 or 3.8. 3.7, equation 3.7. V1 is equal, V1 minus I2 kani nga impedance kay naka-cause na siya voltage drop. I2 0.2 plus J 0.9. So that's equal to, what they call this? Ang V2 na to is 230 minus ang I2 na to is 21.46 angle negative 40.08 times 0.2 plus J 0.9. So that's equal to 214.62 angle negative 3.21 volts. So nanatay V apostrophe. Then now let's solve for V2, the secondary terminal voltage. So V2 is given by the equation N2 over N1 squared times V apostrophe 2. So N2 is the secondary winding, then N1 is the primary winding. So given sa problem is the secondary to primary turns ratio is 5.1. So we have, diretso na nato siyang ibutang. We have 5 squared, then 214.62 V apostrophe negative 3.21. So V2 karon is equal to 1073.09 angle negative 3.21 volts. That's the final answer. So man siya, class. It's just a matter of, playing around the what you call it, the formula given sa dito sa atong module. So that's it. If you have any questions, please leave a comment or just directly contact me, or kung may napansin na mali sa calculations, please notify me as well. So see you next time sa atong catch-up sessions. Thank you so much and stay safe.